Good afternoon, students. I hope you all are doing well. How have you been? So if you can recall the previous session which was being conducted yesterday. My name is Avinav Banerjee and I am over here in order to make you understand the basics of physics before you start this glorious journey for your IIT JEE preparation. So I hope, am I audible to everyone? So if yes, give me a thumbs up. Give me a thumbs up, everyone, if I'm audible to everyone. Yes, good evening, everyone. So today, welcome to this day 2. Today is date 12th of April 2025 and I mentioned that I will be live at 4 p.m. So today we are about to start differentiation. We discussed yesterday about differentiation, but today we are going to be knowing how to perform differentiation. So we already introduced differentiation, isn't it? So once again would like to perform a brief introduction of whatever we studied yesterday. So I will be saying differentiation means change of one variable. So you can start noting it down, everyone. Change of one variable with respect to the other. So once again, if you can recall that I mentioned about one thing, that is, if I am going to be varying y with x, you will be getting a certain curve in between y and x. And the y and x will be having a certain nature. It can be a straight line, it can be a parabola, it can be anything, isn't it? So I mentioned one thing, that y is a function of x. I hope now the voice is clear. Y is a function of x, isn't it? So now I can also write down this as y is equivalent to f into f that of x, f bracket x. Okay, so now what I am about to say is, once again, if you can recall, I mentioned about dy by dx. What does it mean? It means finite symbol let's try to introduce this word, everyone. Infinite symbol change of y with respect to x. Isn't it? That is, what is it actually? We are going to be knowing all the things one after the other. So in this context, we can see that y is varying with respect to x. So now let's try to know how to perform differentiation, isn't it? Of course, notes will be kept on a regular basis. Okay? So now what I was saying is, let's try to know about some properties. The properties are being stated. Before we know about the properties, we need to know about two basic things. Let there are two functions. Let there are two functions. So I can define functions, isn't it? It can be fx, it can be gx, isn't it? So if I say there are two functions, fx and gx. So now if I try to add these two functions, let us say I am trying to perform d by dx of fx plus gx. As a result of that, we can write it down it as d by dx. What is it? Once again, it denotes the change, isn't it? You will be getting the notes, don't worry. So I can write it down it as, you can use this as an operator. Everyone knows how to perform the product of sums, isn't it? In the same way, we are going to be doing this. You can consider this d by dx to be just like an operator, and I can write it down it as d by dx of fx plus d by dx of gx. That's what we can say it over here. So if you are being asked to perform the differentiation of fx plus gx, isn't it? This is going to be the result of it. In a similar way, if I am being asked to find out the derivative of fx minus gx, I will tell you how to do it once we are going to be coming across a question. So we need to know the theory first, isn't it? So if I am going to say that in a similar way, if I am trying to perform d by dx of fx minus of gx, this is going to be written as d by dx of fx, isn't it, minus of d by dx of gx. Okay, everyone? So now I believe that theories, continuous theories, prove out to be a bit of boring. So that's the reason we should be knowing about the ground reality. We need to know how to solve the application part of it. So now let's try to solve this question. So there is a question. I believe that everyone is able to see. I hope everyone is seeing this question. X cube plus 5x square minus of 2. We need to find out the d by dx of this question. Okay, everyone? We need to find out d by dx. Read the question carefully. It's already been given that differentiate the following functions. Actually, there is list of functions which we are about to discuss. D by dx we need to find out with respect to x. So what we need to do? D by dx of, write down, x cube plus 5x square minus of 2. Now everyone knows polynomial, isn't it? Everyone knows polynomial. Let's see who is going to be getting the correct answer. Okay. So this is what, everyone, we are able to see that this is a polynomial, isn't it? And the degree of the can anyone tell me the degree of the polynomial? Please do mention in the chat box. Everyone knows, everyone's giving me the answer. That's really great. Sahi hai? Yes, 3. The degree of the polynomial is 3 over here. So now those who don't know this differentiation, how to differentiate, if I say that let x to the power n is a polynomial of nth degree, then what is going to be the value of d by dx? It is going to be, we can write it down it as, you can note it down, d by dx of x to the power n is going to be written as n into x to the power of n minus of 1. Okay, I hope it's clear. Now if n is equivalent to 3 over here, so we can write it down. See, you just consider this to be as an operator, and you can incorporate this inside the brackets, isn't it? So we can write it down it as d by dx of x cube plus d by dx of 5x square minus of d by dx of 2. Now another thing I would like to say, see, I could have given you the entire rules associated with differentiation, but I'm not giving you in a sequence because it can prove out to be boring, isn't it? So always remember one thing, that d by dx of any constant means anything, a, b, c, even y. If I am going to be performing dy by dx, it is going to be equivalent to 0. d by dx of any constant will be giving us 0. So it's an obvious thing. If you are able to see the term which is situated to the right of this negative symbol, this is going to be equivalent to 0. d by dx of 2 is going to be 0. Now let's try to do this. If I am going to solve this, what is going to be d by dx of x cube? d by dx of x cube, once again it's a polynomial. Most of you people have already answered to me that d by dx of x cube, it's a polynomial of degree 3, isn't it? So I can use this formula over here and can be written over here as 3x to the power of 3 minus of 1. Now plus d by dx of 5x square. 5 is a constant. It can be taken outside this brackets, this operator, you can take it outside. 5 into d by dx of x square minus of 0. So what are we going to get? 3 into x to the power. What is 3 minus of 1? 3 minus of 1 is going to be 2. So I can write it down it as 3x square plus 5. Now what is going to be d by dx of x square? Once again, we need to use this property. This you need to recall forever, because d by dt of t square, d by dt of t, you will be using this forever throughout your physics curriculum, isn't it everyone? So I can write it down it as, the n is 2 over here, so 5 into 2 into x to the power 2 minus of 1 minus of 0. So what I will be getting? 3x square plus 10x minus of 0. So the answer to this question is going to be 3x square plus 10x. Most of you have already provided a correct answer to this. So I hope this is clear to each and every one of you. 6 nahi aayega answer. I haven't given you any value of it. So 3x square plus 10x is going to be the answer to this question. Okay everyone? So now let's try to know certain other things as well. Through questions, I will be giving you a better idea, because I believe that as you all are going to become engineers, you should be knowing about the real application. Where are you going to be applying which of the equations, which of the identities, the formulas, isn't it? So moving to the next question over here, before we, now comes another formula over here. That is, we need to differentiate, exactly Pawan Rama, I am about to mention this right now. X sin x, we need to find out d by dx of x sin x over here in this question. So now which property of differentiation you need to apply? So now let's try to see over here everyone. So now once again we are coming back to those two functions. We are having two functions, fx and gx, isn't it? Once again we are having those two functions, fx and gx are two functions. Okay? Are two functions. So now, if I am being asked to find out d by dx of fx into gx, this dot denotes multiplication. So don't get confused, isn't it? So now I can write it down. See what needs to be done. In this case, initially you need to choose one of the functions to be a variable, the other function needs to be chosen as constant. Plus, the derivative of the other function needs to be chosen as variable, and the first function needs to be chosen as a constant. So let's try to do it. So in this thing, in this situation, you need to choose the gx to be a constant. Gx, let's try to take it as constant initially. It's going to be fx, which I have to choose it to be as a variable. So d by dx of fx into gx, plus now you need to choose the gx to be variable and the fx needs to be chosen as a constant. So I can write it down over here as fx into d by dx of gx. So this is what happens when two functions are being multiplied and you are being asked to find out the derivative. Okay? From the question we can understand it, isn't it? So now what I will be saying is, let's try to do this question using this property. But first of all, you are able to see that there is a trigonometric function. You are able to identify the functions, isn't it? X is an algebraic function or a polynomial of degree 1. And what is sin x over here? Sin x is the trigonometric function, which we are getting it in this context. So what needs to be done? So now if I say you another rule in this context, so I can say that, let's try to note this thing down, d by dx of sine of x. You can note down this property and you should not be forgetting this for the rest of your lives, everyone. So d by dx of sine x is going to be equivalent to cosine of x. Similarly, if I say d by dx of cos of x is going to be equal to minus of sine x. Number 3, d by dx of tan x is going to be equivalent to secant square x. 4th, so we are just trying to find out the derivatives of trigonometric functions, isn't it? Similarly, if I say that d by dx of sec x is going to be equal to secant of x tan of x, isn't it? So you can note down these properties, everyone. Similarly, d by dx of cot x can be written as minus of cosecant square x. And now, last but not the least, d by dx is going to be equivalent to minus of cosec x cot x. So these formulas you need to use in real life. I hope it's clear to everyone. Everyone is able to see what I'm trying to find it out, isn't it? So now let's try to solve this question, the one which I said it over there, isn't it? Yes, definitely these are the notes which you all are going to be getting, isn't it? So now let's try to solve this, everyone. So this was the question. What we have to do is, first of all, we need to use this rule, the rule which I mentioned to the right, how to find out the derivative of two functions which are being multiplied. So this is also known as the UV rule. This is also known as the UV rule, everyone. So now I can write it down over here as d by dx. First of all, take sin x as constant. Over here, everyone is able to find out that in this case, let us say fx is equal to x. Gx is going to be equivalent to sine of x. So I can write it down it as sin x d by dx of x, isn't it? Plus, now you have to take x to be as constant and Sin x needs to be chosen as a variable. So now what do you think? What is d by dx of x? You people say, definitely, Pavan Rama, it will be clear to you. Next question will be based upon u by v rule. So what is d by dx of x? Can anyone tell me? Yes, it's going to be 1. Once again, what needs to be done? It is nothing but a polynomial with degree 1. So once again, I will say this is sine of x into 1 into x to the power 1 minus of 1, isn't it? And x to the power n minus of 1, we are getting it over there, plus x into, what is d by dx of sine x? We have seen over here, isn't it? This one needs to be chosen. That is going to be equivalent to cos of x, isn't it? So I can write it down over there. That is going to be equivalent to cos x. So now let's try to solve this. X to the power 1 minus 1 is, you can say it's going to be 0. So I can say sine x into x to the power 0 plus x of cos x. So as a result, I will be getting sine x plus x cos x is going to be the answer to this question, isn't it? Yes or no, everyone? I hope it's clear. If yes, give me a thumbs up. Definitely chain rule aayega bhi. It will be done, definitely, for sure. Okay, fine, I'm explaining it once again. So over here what we are doing, d by dx of x sin x we are trying to do. There are two functions which are being multiplied, isn't it? So now x is one of the functions, sin x is one of the functions, isn't it? So now in this case, fx and gx, if there are two functions, we need to use it by the means of uv rule, isn't it? So over there is a property d by dx of fx into gx we are trying to do. First of all, you are taking this gx to be as a constant, and only you can differentiate a variable. So that's why we are doing d by dx of fx. Fx is proving out to be a variable. In the next case, plus, after the expression which I am writing it down after the positive sign, it is fx now is being chosen as a constant and gx is being chosen as a variable. So the real life application comes over here. You are choosing fx to be as x, gx to be as sine of x. So over there, sine x is being taken as a constant initially into d by dx of x to the power 1, isn't it? Plus x into, now this time x is being chosen as a constant and sine x is being chosen as the variable. So as a result, I can write it down it as sine x into, you are using the property. What property are we using? Once again, let me try to recall. D by dx of x to the power n is nothing but equivalent to n into x to the power of n minus of 1, isn't it? That's what I'm using it over here. So now as a result of that, it will become what? 1 into, n was 1 in this case, isn't it? 1 into x to the power 1 minus of 1, which is becoming 0, plus x of, we already know that d by dx of sin x is what? Cos x. In this slide itself I mentioned, isn't it, everyone? Yes or no? So as a result of that, I will be getting sin x plus x of cos x. Okay? So now comes another question. Now comes the chain rule, the one which you are saying. Chain rule, isn't it? Let's try to know about chain rule over here. Chain rule is, see, chain rule is an orthodox method. I will write it down over there. It's completely an orthodox method to solve the problem. And after that, I will be mentioning you with the shortcut method. So what do we understand by chain rule? Okay. So let's say you are having a function, okay, y is equal to fx. You are able to see, right? This is a function of x, the function which is being displayed over here, isn't it? So now, if I say that, let's try to assign another variable over here. We are trying to assign another variable. Let z be another variable. So now we need to write it down, the dy by dx, an equivalent of dy by dx. How to write it down? So I can write it down it as dy by dx. If I'm assigning a term z, then can I write it down it as dy by dz into dz by dx. So in other words, what I'm trying to say is this dy by dx can be written of the form dy by dz into dz by dx, where dz by dx we need to find out, and then similarly we have to find out the dy by dz as well. So what needs to be done? See, in formula it's proving out to be a bit sophisticated, but it's an obvious thing, we need to do it, isn't it? What needs to be done? So let's say in this question I will say that let z is equal to 2x plus 3. And what we are having? Y is already being written as 2x plus 3 whole to the power of 6. Isn't it? This has already been given over here. So now I have defined z as 2x plus 3. So now let's try to find out these two terms. First of all, we will try to find out dy by dz, and subsequently we are going to be finding out this dz by dx. So what needs to be done? Let's try to find out dy by dz. What are you going to get? So that means y was what? So can you write down this y as z to the power 6? We can write it down it as z to the power 6 over here in this question. So this becomes, in other words, you are being asked to find out d by dz of z to the power 6 over here. So what are we going to get? We are going to be getting it as, once again, we need to use the x to the power n rule over here. So what are we going to get? It's going to be equivalent to 6 into z to the power 6 minus of 1. Isn't it? Once again, let's try to recall it. You people are learning it, isn't it? It's going to be equivalent to nx to the power of n minus of 1. Isn't it? That's what I used it over here. So I will be getting 6 into z to the power of 6 minus of 1. Then what I will be getting? Tell me, everyone. What do you think it's going to be? 6z to the power 5. So as a result, I am getting dy by dz as 6z to the power of 5. Isn't it? It's going to be 6z to the power 5. Now what we have to do? Now we need to find out this, which is dz by dx. And z was already being given, isn't it? This was the value of z. Now we need to differentiate dz by dx. That means d by dx of z is 2 into x plus 3. Now can you people tell me what is going to be d by dx of 2x plus 3? Give me the answer. Yes, Anushka? I am saying that this is chain rule. For that, you need to assign a different variable, isn't it? Z, let us say z is a different variable over here. I will mention the shortcut as well. So now, after assigning z, this is how we can write down this dy by dx. So it's an obvious thing, it's satisfying, isn't it? dz will be getting cancelled out and I will be getting dy by dx in the end, isn't it? So now in this thing, in this question, I have chosen z as 2x plus 3. Y was being given. This equation was what? Y is equal to fx, isn't it? y was already being given. So I wrote it down it as y is equivalent to z to the power 6. Isn't it? So now first of all I am trying to find out dy by dz. So d by dz of z to the power 6 is being given as, you know that we need to follow this power formula. D by dx of x to the power n is n into x to the power of n minus of 1. Isn't it? So that's what I did it over here. So if you do this, what I will be getting? 6 into z to the power 6 minus of 1. You know that 6 minus 1 is 5. Yes or no? So as a result of that, you got this as dy by dz. Now we need to perform dz by dx. This is done. After that we need to find this. Then we will be multiplying this too. So now what we have to do is, this dz by dx can be written as what? D by dx of 2x plus d by dx of 3. Isn't it? This is how we can write it down. D by dx of 2x plus d by dx of 3. 3 is what? It's a constant. It's a constant, isn't it? So this is going to be equivalent to 0. Now we need to perform d by dx of 2x. So you know that. Let's try to do it over here. So you know that d by dx 2 will be coming outside, and once again we are left behind with d by dx of x, isn't it? So as a result of that, you will be getting, what is that? Once again we are having x to the power 1, isn't it? What I will be getting? D by dx of x is 1. So I can write it down it as 2 into 1, which is 2. So that means the expression which we are willing to calculate, which is equivalent to dz by dx, that is proving out to be equal to 2. Okay? So let's move to the next page. So now once again, what I am doing, I am trying to write down the exact expression of dy by dx, which is equivalent to dy by dz into dz by dx, isn't it? I hope it's clear to everyone. If not, you keep on asking. I will profoundly explaining it over and over again until unless you understand everything. Okay? So now what we need to do? So dy by dz we already calculated over here as 6z to the power 5. Right? So I will write it down it as 6z to the power 5. And what is this dz by dx over here? We got it as 2 over here, isn't it? So dz by dx is coming out to be equivalent to 2. So as a result, I am getting this as equivalent to 12z to the power 5. dy by dx is equivalent to 12z to the power 5. But it's an obvious thing. It's an incomplete answer. Because see, the original function is supposed to be given in terms of x. So what is being given? We have already presumed that z is equal to 2x plus 3. Re-put the value and you will be getting the final answer. So what I will be getting? Dy by dx is going to be equivalent to 12 into z was 2x plus 3, isn't it? This value is being taken. So it's going to be 2x plus 3 whole to the power of 5. So this is going to be the final answer. Okay? Explain from equation. Which equation you need, Jashwant? So see, I believe that this is a long method, this is an orthodox method, this is what you need to do for your school examinations actually. But for JEE, how? Okay, fine, I am explaining it once again. So dy by dx is the derivative. So dy by dx can be written as, we are assigning a third variable, that is z. So I am writing, we can write it down it as dy by dz into dz by dx. Okay? So now first of all, we need to find out this dy by dz. Subsequently, we need to find out dz by dx. Multiply them, we'll get the final answer. Okay. We cannot differentiate 6z to the power 5 once again because it's not required. If they would have asked us the second derivative, then we would have done it. Okay. So now what I did is, z is being given as, we chose a third variable. Let's say z is equal to 2x plus 3. Okay. Now first of all, you find out this. This should be the first thing which is being required to be found out, which is dy by dz. I found out dy by dz first. It obviously the function is becoming z to the power 6. It is becoming d by dz of z to the power 6 is 6z to the power 5, isn't it? Subsequently, we are having this dz by dx over here, isn't it? So that is proving out to be d by dx of 2x plus 3, because we have already chosen z to be as 2x plus 3. As a result of that, if I am doing it, you know how to perform differentiation of addition, isn't it? Differentiation of sum, in other words, yes or no? So as a result of that, you will be getting it as 2, and as in the end, we just multiplied them, 6z to the power 5 into 2, you will be getting 12z to the power 5, re-put the value z as 2x plus 3, and you will be getting the answer as 12 into 2x plus 3 to the power 5. And there is a shortcut method. Now comes the shortcut method. What needs to be done? Because we are over here to teach you the shortcut methods, isn't it? So what was being given? That was d by dx of 2x plus 3 whole to the power 6, isn't it? We need to find it out this. In order to find out by the shortcut method, you choose this 2x plus 3 to be a function. Function means you choose it to be as your x. Let's say it is x to the power 6. What is d by dx of x to the power 6? You can directly treat as d by dx of x to the power 6, which is 6x to the power of 5, isn't it? But it should not be the answer, because we were having 2x plus 3 as well, isn't it? So what you need to do? You need to multiply once again with this term, which is 2x plus 3, isn't it? So now, it's an obvious thing, this is not x, by the way. The one which I got it as x to the power 5, that is also not x at all, isn't it? What it would have been, that is nothing but 2x plus 3, you just re-put the value, it has 2x plus 3 whole to the power 5. Let me write it down properly, what I'm just trying to say. This is, you treated it to be as your x, isn't it? You know that d by dx of x is, x to the power 6 is 6x to the power 6 minus 1, which is 6x to the power 5. Obviously that is not x, isn't it? We are having something in between. So what are you going to be writing it down? This has 6 into 2x plus 3. Write it down once again. So what to the power 5. So what I will be getting? The same thing, d by dx of 2x plus 3, you will be getting it as 2, isn't it? So once again, 2 into 6 into 2x plus 3 whole to the power 5. So as a result, I will be getting it as 12 2x plus 3 whole to the power 5. This is the shortcut. You treat it as x. Okay. Hindi में okay 2x plus 3 to the power 6 दिया हुआ था, isn't it अजय? तो it's an obvious thing, आपको दिख रहा है इधर. इसको आप ट्रीट कर लीजिए x की तरह, and then x to the power 6 का डिफरेंशिएशन क्या होता है? 6x to the power 5. बट ऑब्वियसली आप इसको x तो नहीं लिख सकते बिकॉज आपके उधर 2x plus 3 दिया हुआ है, isn't it? तो आपने उसको रिपुट कर दिया. बस only thing which you need to do is multiplying it with 2x plus 3. Yes, definitely inverse trigonometric functions I will mention. Let us complete this. Okay, Shamla. Not a problem. Okay, someone asked me in Hindi, so that's why I said in Hindi. So this is going to be the answer to this question. So this is what the chain rule is all about. Okay. Now let's try to solve another question, x by sin x. So some people of you were saying what is u by v rule? What is u by v rule, isn't it? So now let's try to know about this u by v rule over here. So I will be saying that once again, let's say we are having two functions fx and gx, and we are supposed to find out the d by dx of it. Same thing we need to do, isn't it? Same thing we need to do, whatever we did for the product of two functions. Now the thing which will change is, first of all, you treat fx to be as a variable and the gx to be the constant. So we can write it down as gx into d by dx of fx. That's the first thing which I wrote. Now, in the previous case, in the case of multiplication, I chose a negative term, isn't it? I chose negative. So what I will be doing it over here, it was positive, this time it's difference, it's division. I will be choosing a minus sign, and this time fx needs to be chosen as constant and gx needs to be chosen as the variable, divided by gx whole square. This is what u by v rule means. So now in this question you are being given two functions. One of the function is fx is equivalent to x, gx is equivalent to sine of x. Now what needs to be done? You have to differentiate them, you need to follow the order, isn't it? So it's going to be sine x into d by dx of x minus of, now you are choosing x to be as constant, x into, obviously it's an into sign, so in order to avoid confusion I will be using dot to denote the multiplication. X into d by dx of sine of x whole divided by sine x ka whole square. So what I will be getting, d by dx of x is going to be equivalent to 1, isn't it? So I can write down d by dx of x is going to be equal to 1. So it becomes sine x minus of, what is d by dx of sine x? We already discussed, right? D by dx of sine x is, say everyone, what is d by dx of sine x? It has to be cosine of x, isn't it? Divided by sine square x. So the final answer is going to be sine x minus of x cos x by sine square of x. You can solve it furthermore by using trigonometric functions, isn't it? You can solve it by using some properties of trigonometry, and you can deduce it furthermore as well if you want, taking sine x as common, isn't it? UV rule, you can use it, yes, definitely, Saket. You can also do it like this, x into 1 by sine x is cosec of x. Then you can use UV rule to get this. You will be getting the same answer itself. D by dx of cosec x is, we have already discussed it, right? Over here you can see, isn't it? So that's it for today. And before we end up the session, this question I am giving you as a homework. I want every one of you to solve this as homework. We are going to be discussing this question initially on Monday. We'll meet on Monday at 4 p.m. First of all, we'll try to discuss this question, isn't it? So this is your homework for today. Thank you. So chemistry sir is going to be joining subsequently. So now what you want to ask, you can ask. Let's have a discussion about certain things. So now, if you really want to understand differentiation, you can follow certain books. From R.D. Sharma, you can solve certain differentiation questions, or those who are already affiliated to Sri Chaitanya, they can follow the Sri Chaitanya module, objective module. And you can follow R.D. Sharma as your reference book in order to understand differentiation. You can solve some more questions. You will be getting the notes, don't worry. Okay, so I hope you enjoyed the session. If yes, give me thumbs up, give likes. I need likes, lot of likes from you all. Lot of likes I need. The number of likes should be more than 2000. It can also exceed 3000 as well. Okay, so meet you on (4 p.m. 16:00 IST). You will be shared with the notes. So go and practice differentiation, some basic differentiation questions. You can also put your questions over there in the chat box as well. Okay. Yes, Siri, I think so. You are correct. Okay, fine then. Need likes over there in this video. Okay, bye. Good night. Have a good sleep. Practice questions from these two books. If you don't have the Chaitanya objective module, go through R.D. Sharma. Thank you very much. It's Avinav Banerjee for you. Departing for time being. Thank you. Meet you at Monday, 4 p.m. Indian Standard Time. Thank you very much.